Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are continuing our adventure with the derivative function. And now we're going to find the slope at a specific point on the curve. It's going to grade. It's going to be great. So let's get to it, shall we? Okay. So here we are. Find f prime of 2 for f of x equal to 3x squared. Well, what does that mean? Well, that means find the derivative of f of x for x equal to 2. So we have to find the derivative first, and then once we find that, we replace x with 2. Okay? So the first thing we're going to do is find f prime of x, or the f prime of x. And recall that is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so in this particular case, the original function is 3x squared. So I am going to take the 3x squared here, and I am going to replace this x with x plus h. So this becomes the limit as h approaches 0 of 3 times x plus h, the quantity squared. So I've taken care of this. Ka-ching! Minus f of x, minus the original function, minus 3x squared. And as you have learned by now, this is always going to drop out. And if it doesn't, then you've done something wrong. All over h. So this is equal to 3, and we've worked on knowing that x plus h squared expanded is always going to be x squared plus 2xh plus h squared minus 3x squared over h. And I forgot to put the limit as h approaches 0, because we can't use, we have to remember we can't use the direct substitution yet, because we still have h in the denominator and we can't divide by 0. So that equals the limit, almost done here, as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 3x squared. And what did I do? I just distributed the 3 through the parentheses all over h, and things are starting to look better. The 3x squareds go away, and so now I have the limit as h approaches 0 of, what do I have left? 6xh plus 3h squared. So that means I can factor out an h times 6x plus 3h all over h. And isn't life wonderful now? Because we get to do kapow. And the h is gone from the denominator. So now I can do direct substitution of 0 for the h, and 6x plus 3 times 0 is simply equal to 6x. So what we are saying is that the derivative of the function 3x squared is equal to 6x. Okay? And so f prime of 2 is equal to 12. Now what does that mean? Well, that means at the original function, 3x squared, the slope of the tangent to the curve, the derivative, the slope of the tangent to the curve, when x equals 2 is 12. And I just want to show you that real quick. So we're going to graph 3x squared. Okay, looks like that. And I'm going to drag it down a little bit, and then I'm going to do the tangent, points and lines. I want to do a tangent line, and I'm just going to put it on this graph and do this point real quick, and I'm going to hide that because I don't need it. I don't need the equation. Hide. Okay, and I'll stretch this out a little bit more. But what I am going to do is I'm going to put the coordinate there. So that's 1.43. And I need it to be when x equals 2. So I'll just change that to 2. And it'll go to x equals 2. And we can't see it. So I need to drag it down a little bit. I'm going to get that out of the way. So that's the point when x equals 2. In other words, if I went straight down here, x would equal 2. Okay? And what we're claiming is at x equals 2, the slope is 12. Now it's just a coincidence that the y-coordinate here is 12 as well. But I'm going to go ahead and measure slope of the line, and you saw there that it is 12. And you can see that it changed, just so you see that it doesn't see that it's just a coincidence that it's equal. Like right here, the slope of the line is 11.3 and the y-coordinate is 10.6. So that was just a coincidence that it was the same. Okay, next example. One more example. We're going to find the derivative of f of x when x is equal to negative 3. And again, the derivative gives us the slope of the tangent line to the curve. So f prime of x, again, the derivative of f of x, pen's acting up, is equal to the limit as h, come on, be nice to me, let me erase that. Okay, so that's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And again, all I'm going to do is I'm going to take this x plus h for the first part and put it right in for x. Okay, so this will equal the limit as h approaches 0 of 2 times replacing x with x plus h. That becomes x plus h squared. And don't forget the minus 5. That's part of the function. Minus 5. Okay, so I've taken care of this. Now I'm going to subtract the original function, and since there are two terms, I need to use parentheses, so I remember to distribute the negative through the parentheses. All over h. Okay, and so then, remember, we know what x plus h squared is, so that's the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared minus 5 minus 2x squared, distributing the negative through here, and then minus a negative 5 is actually plus 5, which is good news if you see it, all over h, because a negative 5 and a plus 5 cancel out. So now we're going to do a little bit more algebra and distribute the 2 through here, so that would be 2x squared plus 4xh plus 2h squared minus 2x squared all over h. Kaplooey again, 2x squared minus 2x squared, gonzo. So that equals the limit as h approaches 0. And this is where we see, okay, what do we have left? We have 4xh plus 2h squared. So we can factor out an h. And we have 4x plus 2h. Over h, yay, kapowie. And finally we can substitute 0 for h because we won't be dividing by 0. So this becomes 4x plus 2 times 0, which is 4x plus 0 or 4x. So again, let me go up here. What we're claiming is that for this function f of x, the derivative is equal to 4x. And so when x equals negative 3, the derivative at negative 3 is equal to 4 times negative 3, which is, that looks horrible, 4 times negative 3, which is negative 12. Again, what we're claiming is the slope of the curve at this point when x is negative 3 is negative 12. So let's take a quick look at that again. So we'll get rid of all this. And we'll put in, let's see, what's the original function? It is 2x squared minus 5. 2x squared minus 5. So it looks like that. And then we'll do the tangent line again. Points and lines, and we want a tangent line, so I'm going to put it there. Okay. Escape. And let me make it a little bigger. Okay, and then we need this. I want to hide that. Okay, and x equals -3, that's way there. So I'm going to go way up high. Actually, let me get the coordinates. And I'll go ahead and change that first. So this is a -3, because that's where we're interested in. And it's going to go zooming up there. We can see the end of it, right? There it is. But let's just go where we can see -313. So we're claiming that the slope of the tangent line to the curve when x is -3 is 12. So I am going to measure that just to prove it to you. Measure slope. I'm going to select this line, and then you're going to see it's -12 right there. And just to convince you, I'll just show you if I change it, you can see that the slope changes as it should. And then we go back to -3 and it's -12. Okay, that is all I have. We will end it with some more Angels and Airwaves. Hope you enjoyed it. And we will see you next time because I am